Hello, welcome. So nice to have you in this first episode of Research Recap for the Future. Let's dive in. In this first episode, I will take you through some of the work already published, which we've done, and point out directions, some aspects that will have importance for the future. I am Andrew Ekbayan, and I am a Catholic priest and an associate professor of physics in Creighton University, Omaha, Nebraska, United States. So this first episode, the paper we published based on the work is titled Determination of Cell Elasticity through Hybrid Ray Optics and Continuum Mechanics Modeling of Cell Deformation in the Optical Stretcher. That's a tongue twister. That's a lot of work. We're basically using matrices, using linear algebra to solve differential equations arising from a particular application of light being used to stretch cancer cells in the optical stretcher. So for the future, matrices will continue to be very important for the linearization of nonlinear phenomena. In the particular research we published with the title in red font, it was the tridiagonal matrix, which I show here, tridiagonal. So non-zero elements are only in three. So the diagonal, the superdiagonal, and the subdiagonal. And inverting and other methods for matrix solutions are easy. And this can be done quickly, numerically, using, I used C++, but now MATLAB, matrix algebra is the go-to software for it, and many other software applications and packages do the same stuff. So linear algebra will continue to be very important. So here is the paper in case you're interested in details of how we used the ray optics model and continuum mechanics model, solved equations of deformation in the optical stretcher, basically in the form of Euler-Lagrange differential equations, linearized them with matrices, into matrices, and then solved them, and then carried out our simulations. A lot of fun. All right, and with fun people too. That's the end for this first episode of Research Recap. In one sentence, linear algebra, matrices will continue to be important for the future in solving several problems, especially nonlinear ones that are all around us and within us. Thank you.